ZIMSEC Mathematics Paper 1 Syllabus 4004. So this Paper 1, November 2023 session. The time for the paper was 2 hours 30 minutes. And the important instructions here are candidates answer on the question paper. So there will be working space or the answer space on the booklet. Additional materials you can carry into the exam are just mathematical instruments. So let's dive in. But before we dive into the paper, we need to check on the analysis of the paper, because if you are revising, we need to analyze. So these were the topics tested. We have algebra, real numbers, geometry, graphs, probability vectors, variation, matrices, statistics, sets, trigonometry, and measures and mensuration. So there were 12 topics tested, 26 subtopics, 55 principles, which means the total questions, if we are counting in parts, we have 55 principles, then it was allocated 100 marks. And here I've ordered the topics according to the order of questions. So there are 14 questions from algebra, which contributed 30 marks. There are 12 questions from real numbers, which contributed 14 marks. So this was the order of importance. So the first 5 topics were algebra, real numbers, geometry, graphs, and probabilities, which had more marks than other topics. Now let's start on number 1. So number 1, this was real numbers. Express 4.695 to 2 decimal places. So the first step here is to identify decimal places or to understand decimal places. So decimal places here, we started 6. This is the first decimal place. So 1, 2, 3. So we have 3 decimal places. They want us to write an answer with 2 decimal places. So I'm labeling my decimal places and counting them 1, 2, 3. But I need to remain with 2 decimal places. So I check on the next decimal places, which is the 3rd decimal place. If it is above 5, it affects my number. If it is below 5, it does not affect 9. But in this case, it affects 9 because it is above 5. How does it affect 9? So 5 affects 9 so that it becomes 10. So my 9 I replace with 10 on that 2nd decimal place. But I cannot write 10 as a single figure. So I will push 1 to 6. Then I will remain with 0 here. This means I have 4.70 as my answer. So that's how we write our answer to 2 decimal places. On part B, 794.3 to 1 significant figure. We must understand significant figures. Significant figures does not consider commas, it considers numbers above 0. So in this case, 7 is above 0. So this becomes our first significant figure. So 7 becomes our significant figure. So this number is expressed to 4 significant figures. So these are the 4 significant figures of this number. But we want to remain or to write it in 1 significant figure. So we consider 1 significant figure and look to the next. If it is above 5, it's going to affect 7. And we replace everything by 0. If it is below 5, we just leave 7 as it is and replace everything by 0. So in this case, 9 is above 5. So we're going to affect 7. How? 7 becomes 8. So we write 8 in place of 7. Then everything becomes zeros. So we must respect the commas. So we can write it as is, like 800.0, or we can just write it as 800. Final answer. Then to part C, this was standard form, also under real numbers. So 0.00231. Now we have different methods here. The easiest one I prefer is counting zeros and put a negative power of 10. So 0, 0 here, 0. I will count my zeros. We have 3 zeros. So I write my answer as 2.31. So this is the standard form number. Standard form number is between 1 and above and below 10. Between 1 and below 10. So 2.31 is a standard form number. Understand standard form numbers. So 2.31 times 10 to the power negative number of zeros is 3. So 10 to the power minus 3. This will become my final answer, short and precise. Or we can count commas. It's another easy method. Here, my comma is here. I want to move it to the standard form number to 2.31. So it's 1 here, 2 here, 3. So it's 3 movements of the comma. So which means I'm going to put my power as negative 3 because the number is less than 1. So these were the 2 methods, shortest method you could use. You can use 231 over 100,000 and then simplify further until you reach this answer, but that will be longest and the space might deny you smart presentation of the answer. Then we go to number 2. So number 2 here was about number bases which are grouped according to powers. Right, let me just do this so that you can see. So here I will write down the full question so that you can see. So the full question here was 7 by 8 to the power 3 plus 8 plus 6. This was the question. Let me write it in a way that you can see. 7 by 8 to the power 3 plus 8 plus 6. So let's calculate it. So we group it like this. We write the bases here. We write the powers of the base. So this base 8, then the powers 0, 1, 2, 3. So these are the increasing powers. So under 8 to the power 3, what is the number that is multiplying 8 to the power 3? In this case, it's 7. So I must write 7 here, so that it represents 7 times 8 to the power 3. Then the number here that is multiplying 8 to the power 2, we don't have that number, so it will be 0. It will be 0. It will be 0 here. This is 8 to the power 1. This one is 8 to the power 1. So the number that is multiplying 8 to the power 1 is 1. Right? Because we have 8 to the power 1. So it's 1. So let me write it. And here we just have 6. It means we are saying 6 by 1. And 1 in basis of 8 is 8 to the power 0. So how many, what the value of the number multiplying 8 to the power 0? It's 6. Because 6 by 1 is 6. Or 6 by 8 to the power 0, it's 6 again. Because 8 to the power 0 is 1. So that was the shortest way you could identify the correct number of base 8. Or you could expand this number. You could expand this number. How? So this was method 2, expand to base 10. So 7 by 512, 8 to the power 3 is 512 plus 6 plus 8 plus 6. So this was going to give you 3,584 plus 8 plus 6. If you add this, you'll get 3,598. Then you convert 3,598 to base 8. So you reach the same answer. Let's go to the next. So I'll write my answer here, 7016 base 8. Then on part B, 57 base 10 to number in base 6. Method 1, you could divide 6 into 57, then take the remainders, reading them upwards. That is 6 into 57 is 9, because 6 times 9 is 54, so it will remain that 3. It will remain that 3, right? 6 into 9, that will give me 1, remainder 3. 6 into 1, that's 0, remainder 1. So if I have 0 here, it means I now have my answer reading upwards. I'll read upwards. So this will be 1, 3, 3, base 6. Method 2, we don't want you to stick to a single method. Just have many ways to kill a cat. Method 2, 57 base 10 today, it's a number in base 6. You can group them by powers. Right, we have 6 to the power 1, 6 to the power 2, 6 to the power 3. So the trick of this method is to check for the highest powers of 6 that can be divided here. So 6 to the power 1, yes, it can be divided, but it's the smallest. 6 to the power 2 is 36. Yes, 36 is in 57. It's also possible to divide 6 to the power 2, which becomes highest at this point. 6 to the power 3, which is about 216, it cannot be divided into 57. So we consider 6 squared, which is 36. So if we subtract 36 from 57, we rewrite it as 36 plus 21 to give us 57. Now we want to consider the next powers. 6 to the power 1 can be divided into 21. How many 6 to the power 1s we have here? We have 3. So we can write it as 36 plus 3 times 6, which gives us 18. Then we have a remainder of 3, so we add 3 here, put a plus 3. So 36 plus 18 plus 3, it still gives us 57. Now we want to rewrite them as powers. If you want to expand the base to C, so this will be 6 squared plus 3 times 6 plus 3 times 6 to the power 0. So we can rewrite them as a base. So our base is 6, then our powers 0, 1, 2. So a value that is multiplying 6 to the power 2 is 1. Value that is multiplying 6 to the power 1 is 3. Value that is multiplying 6 to the power 0 is 3 again. So we can write it as 1, 3, 3, base 6. So there's also another method, but I've just explained 2 methods. Let's go to number C. 1, 1 base 2 plus 1 base 2, giving you answer in base 2. So this adding number bases, under topic of adding number bases. So 1, 1 base 2 plus 1 base 2. When we are adding, we can use a direct method, which is easy for me, or you can convert them to base 10, then you convert them again to base 2. So 1 plus 1, it gives me 2. But because I'm in base 2, I must divide my answer by base 2 and write the remainder here and carry the answer. So here 1 plus 1 is 2, then I'll divide that 2 by the base, which is 2. 2 divided by 2 is 1, remember that's 0. I'll write 0 here, then I'll carry 1 here, like this. 1 plus 1 is 2. 2 divided by 2 is 1 minus 0. Then we also here 1 plus 1, which is 2. So 2 divided by 2 is 1 minus 0. We write a 0 here, and we carry our 1. Now that we have remained with 1 here, 1 plus 0 is 1. So we have to divide that 1 by the base, which is 2. So 0 remainder 1, we write 1 and carry 0. So my answer becomes 1 0 0 0. There's 2. That will be my final answer. Let's now start on number 3. So the question is 0 to 17 is a time in 12 hour. So for 12 hour, we have to put AM or PM. If it is above 12, we subtract 12. So in this case, it's 2.17 AM, 17 past 2 AM. So AM shows us the answer. You remove 0 here. We do not write zeros before a number in time, which is expressed in 12-hour notation. Right. For a general parallelogram, state the number of lines of symmetry. Lines of symmetry, these are lines which divide our shape into two similar parts that look exactly the same. But for parallelogram, let me draw it. We don't have that one. So there are no lines of symmetry. We cannot draw a line that divides our shape into two equal parts that are identical. So there's no line of symmetry. So it's 0. Now we have the order of rotational symmetry. If we rotate the angle, how many times do we rotate the shape to look the same? So in this case, we can rotate it so that it sits on the other side. It's 1. Or we can rotate it in vertical like this 2 times. It remains the same shape. It looks the same. So it has 2 order 2 of symmetry. So this was easy. Then we are given a function here, f of x is equals to 3x minus 1. Find f, then in bracket, minus 2. So if you see a functional notation like this, it means this is a substitution. We are going to substitute. We are going to substitute here. We are going to substitute x with minus 2. So our answer will be 3 bracket minus 2 in place of x minus 1. 3 minus 2 is minus 6 minus 1. Then it's minus 7. So our answer is minus 7. We write our answer is minus 7. If x, find x if f of x is equals to 5. Now this becomes an equation because now we have an equal sign, which means we're going to replace our function of x. 3x minus 1 is equals to 5. So 3x minus 1 is the function of x is equals to 5. So this is an equation. Now for our equation, let's solve it. 3x minus 1 is equals to 5. So this will be 3x is equals to 5 plus 1, which is 3x is equals to 6. We divide by 3 both sides, which is x is equals to 2. So our answer is 2. Then on number 5, simplify minus 3m to the power 4. We must learn to divide or to separate these numbers. So minus 3 is a separate number. M is a separate number, which can be raised to the power 4. So in this case, minus 3 to the power 4. Note that minus 3 is in brackets, so this negative will be affected. So minus 3 to the power 4 is positive 81. Then m to the power 4 remains m to the power 4. If we multiply them with 81, m to the power 4. So this was our final answer. Let's go to 5b. Evaluate 49 3 over 2. 49 to the power 3 over 2. So under indices, when we are learning indices, we now understand that this type of indices are called roots. We will be finding roots here. So this denominator is the root, so the square root of 49, then this numerator will be the power to the power of 3. Then the root of 49 is 7 to the power of 3, 7 to the power of 3 is 343, so this will be our answer. Now on part 2, 2 to the power minus 3, under indices again, if our index is a negative, it automatically becomes a fraction with 1 is a numerator. So 2 to the power minus 3 is 1 over 2 to the power 3. These are fractions. 2 to the power 3 in ordinary terms is 8. So our answer will be an eighth.